The Earth is a water planet, but global water resources are under attack. From dead zones to acidic oceans, vanishing groundwater to rerouted rivers, our water planet is changing in ways that threaten us all. The good news is, solutions exist, and Earth Echo is on an adventure to find them. I'm Philippe Cousteau. Join me as we explore how the most precious resource on Earth is driving some of the most exciting innovations in engineering on Earth Echo expeditions, Water by Design. Scientists, engineers, and policymakers in Southern California have developed diverse innovations to recycle, store, and conserve fresh water in the area. But there is another, relatively controversial solution that I wanted to explore. Our team traveled to the West Basin Municipal Water District's Water Education Center to speak with Daryl Ramos-Young about desalination. A desalination seems like an obvious solution for coastal communities, but it's not a simple one.
We're really interested in one technology that you've all been investing in and researching. Tell me about it.
So ocean water desalination, which is a very old technology for decades, countries in the Middle East have been using it for their sole water source. Here we feel as an agency, coastal water agency, it's our obligation to take a look at a potential water supply in our backyard, the Pacific Ocean.
Daryl explained the 8-year-long pilot study that West Basin has undertaken to examine desalination, the process of taking in salt water from the Pacific Ocean and converting that salt water into drinking water. The first challenge is protecting the marine ecosystem while drawing in the salt water.
So we've basically tested putting a wedge wire screen over the open pipe to prevent the juvenile and adult fish from being drawn in. And this is an example of a smaller version of the wedge wire screen. The notches or the holes are too small, basically the size of a credit card. So the adult and juvenile fish are protected from entering into our pipeline. So once the water is drawn into the pipeline, the water first goes through pre-treatment through our ultrafiltration membranes.
So water can pass, the water molecules can pass, but nothing else.
And the salts make it through there too. So the next thing to remove the salts is we run the water through reverse osmosis membranes. So the water molecules are the only elements that can pass through these membranes.
And basically, even the salt is too big then.
Exactly. So all the salts get left behind, but the water molecules are able to pass through these holes.
So the water is pressed through here.
Lots of
as
pressure.
It makes its way through all these sheets, individual sheets, it ends up in this pipe and
Exactly.
it's piped out.
Yeah, and so you can see. So from the center pipeline comes the clean drinking water.
I really like that approach, that it's a diversified approach to protecting and saving water here in Southern California. And these are the kinds of technologies that can apply all over the world.
Since desalination is used in many parts of the world, I wanted to examine the known challenges to utilizing seawater as a source of fresh water. Mitigating environmental impacts is an important step, but what about the energy needed for this process? How does desalination compare with processes like groundwater recharge or even importing water?
Now, Daryl, one of the challenges traditionally for desal has been it takes a lot of energy to make it work. So what are you all doing about that?
Yeah, so for a typical reverse osmosis membrane that's providing desalination, it could require 900 pounds per square inch. That's a lot of pressure to exert on the water molecules. But somebody realized, hey, the brine that is not passing through this membrane is actually exiting the membrane under intense pressure also. And it'll be discharged and the energy will slack off before it goes out to the ocean. Well, somebody realized they can harness that energy from the brine, capture that energy, and repower the pumps, putting the water in the first place so you can reduce the amount of electricity that's required to turn on your pumps. So this is an energy recovery device. And what it does is it harnesses the brine that's going out of the membrane that's under intense pressure, spins this little ratchet device inside, and the incoming ocean water gets pressured up as it enters the membrane itself. So it's a great exchange of energy. Energy loss is actually turned into energy gained. put into the membrane itself.
How much energy savings is there? Is this really early stage technology?
No, this is a pretty old technology now. It was invented about 5 years ago. Many water treatment facilities, from drinking water treatment facilities and water recycling facilities, are using this technology to reduce their energy costs. For our research facility, it reduced our energy costs by 35%.
Wow. What kind of research have you been doing regarding the brine and the potential environmental impact of that super salty water going back into the ocean?
Right, we really wanted to make sure that it wouldn't impact the marine environment discharging that brine. So we did 2 studies. One study was a long-term study to see the effect of potential higher salinity water on the marine organisms that live in Santa Monica Bay. We had one tank with native animals living from the bay itself in raw ocean water, and in the other adjacent tank, the same species, the same life stages, and then we did 3 tests to increase the salinity levels in that water to see if their behavior changed, if their reproductive ability was altered. And we determined that there was a certain level, 42 parts per thousand, that the most sensitive organisms should not be exposed to because that would potentially harm them. So that was one study where we identified that measuring point. The other study is taking a closer look at some of the embryonic stages of the marine life out there and adding high saline waters to them to see how that would potentially affect their growth. By law, the brine needs to be back at ambient or the surrounding ocean water within 100 meters. We determined through our mathematical calculations and research that we could have the brine back to ambient salinity within 8 feet.
Terrific.
So desalination is a great potential alternative, but the agencies or water companies undertaking it need to do their thorough research because every site is different. So they have to consider the species in that particular area, the tidal zones in that particular area, the geology. Because desalination, there is not one answer that fits all for each site.
Leaving West Basin, I couldn't agree more that this is not a one-size-fits-all answer for managing water resources. Here in Southern California, we've brought water to the desert, but can we continue with increased pressure from climate change and severe stress on global water resources? Ocean desalination could be a part of a diversified water resource management plan if we engineer solutions that are sustainable. To learn more about freshwater resources and find ways to take action in your own community, visit EarthEcho International at www.earthecho.org.